Hey students, this is lesson 2.6. We're going to learn how to prove and apply theorems about angles. This will be new to you, so you might want to pay extra close attention. Go ahead and do the review. Okay, we're going to prove some things about angles, and to do that we need a couple theorems. Here's one of the theorems we're going to use. It's the vertical angle theorem. We will eventually just abbreviate it VAT. We're going to use this one a lot. If angle A and angle B are vertical angles, then the measure of angle A equals 15, then the measure of angle B is 15. Vertical angles, just to remind you, are if you have two intersecting lines, the angles that are opposite, these two are vertical angles, then it turns out that they're always congruent. And we'll prove that in a little bit here. But right now we're just going to use that. So we can see that these two angles should be congruent. So by the vertical angle theorem, we can write 2x plus 42 is equal to 3x minus 10. Then we're just going to subtract 2x from both sides, and we get x minus 10 equals 42. Then we'll add 10 to both sides, and we get x is equal to 52. And that's using the vertical angle theorem. All right, you can practice that. All right, so if we're going to use this theorem, we really should prove it, and hopefully throughout this we will get where we prove most of the things. Theorems are a little bit different than postulates. Postulates we just assume are true. Theorems we like to prove them, and then once we prove them, we can use them wherever we want. But so here we have proof of theorem 2.1, vertical angle theorem. Given angles 1 and 3 are vertical angles, prove that angle 1 is congruent to angle 3. So the two red angles here, we're going to prove that they're the same. And this is called a two-column proof, and this is what we are going to practice. In one column we have the statement, in the other we give the reason. That's one type of proof we'll use. So we're going to start here at number 1. We have angle 1 and angle 3 are vertical angles. And that's just by the definition. Oh, that's given to us. But we could also say they're vertical by definition because of the way they're situated in the intersecting lines. Angle 1 and angle 2 are supplementary. Angle 2 and 3 are supplementary. And we're going to say, right now, eventually we'll just say linear pairs, but we need to know that every time you have a linear pair, they will be supplementary. So we'll say linear pairs are supplementary. All right, and then step 3, it says the measure of angle 1 plus the measure of angle 2 equals 180. That's these two added up, they equal 180. Measure of angle 2 plus the measure of angle 3 also equal 180. And that's by the definition of supplementary angles. And then we can now say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And you can see that this equals 180 and this equals 180. So by the transitive property of equality, we get measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. Now, if we take away this measure of angle 2 from both of them, we end up with step 5, which is measure of angle 1 equals measure of angle 3, and that's by subtracting measure of angle 2 from both sides, which is a subtraction property of equality. And then the last step, if we say the measures of two angles are the same, then we're saying the two angles are congruent. I call that the definition of congruence. The book calls it something a little bit different, but we're going to go with that. All right. right, we're going to do one more proof together, and then I'm going to let you try one. And this proof, so in this one we're given that angle 2 is congruent to angle 3, and we're going to prove that angle 1 is congruent to angle 2. And we're going to use the vertical angle idea to help us do that. So I'm going to make 2 columns, one side for my statement, the other side for my reason. And usually your first step is the given. Angle 2 is congruent to angle 3. Sometimes not, but usually. Now I'm going to say angle 3 is congruent to angle 1, and that is because they are vertical angles. So it's the vertical angle theorem, soon to be known as that. And then now I'm going to say angle 1 is congruent to angle 2. And you can see what's going on here. Notice we have the angle 3 in 2 places, so these 2 should also be congruent. And that's by the transitive property of congruence. All right. I'm going to let you try this, see if you can fill in the reasons. Check back, see if you're right. All right, theorem 2.2, another one we're going to use is the congruent supplements theorem. What that says is if two angles are supplementary, and another angle is congruent to one of the 2 supplementary angles, then that will also be supplementary to the other one. So go ahead and fill in what you think goes here. Hey, for this one, we're going to write a different kind of proof. It's called a paragraph proof. In this one, we're given that angle 1 and angle 2 are complementary, and angle 2 and angle 3 are complementary. So we're going to prove angle 1 is congruent to angle 3. Basically, what we're proving here is the complementary supplements theorem, just like we just had the congruent supplements theorem, I'm sorry. So this will be proving the congruent complements theorem. So anyway, basically we're going to write this in, just kind of write it out in sentence form. And we're going to start by saying that angle 1 and angle 2 are complementary, and so are angle 2 and angle 3, because it is given. That will be our first sentence. And then we're going to say that and our second sentence will be something like, then the measure of angle 1 plus the measure of angle 2 equals 90, and the measure of angle 2 plus the measure of angle 3 equals 90 by the definition of complementary angles. Our third sentence will be something like, then the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3 by the transitive property. Then we'll say by the subtraction property of equality, the measure of angle 1 is equal to the measure of angle 3. And finally, our last sentence will say that angle 1 is congruent to angle 3 by the definition of congruence. I like the word therefore at the end. It kind of makes it like we really proved it then. So the rest of it is just kind of for you to check your work. I'll put in the answers here and you can check back. And congruent complements theorem, this is the one we just proved, so we can go ahead and use that now. But basically it's saying if you have complementary angles and another angle is congruent to one of them, then it is a complement of the other one. So go ahead and finish this up and check out these other couple theorems that we're going to be using. do the lesson check, and I'll see you next time we meet in class.